as the Bates et al. Study got us to thinking, well, what are these different situations in which adding disfluency or difficulty or increasing cognitive demands could be beneficial in some ways. And there's all kinds of other examples of this in the literature, and so I'm just going to point to a couple of them. So, in other words, we typically argue that you should reduce cognitive load, especially when it's extraneous cognitive load that is not relevant to the message being conveyed. Are there situations where you actually increase irrelevant cognitive load and benefit the viewer? Okay. And there are other examples out there in the literature. So the first example you may be familiar with is work of Oppenheimer and others, which finds that the font itself has an influence on comprehension. They've done a variety of different studies. So we kind of like easier to read fonts, right? So I'm going to put the fonts up here. That one is definitely easier to read than the word Letty, 2 feet tall, eats flower petals and pollen, has brown eyes, versus the pangarish. These are alien species in a study by Oppenheimer and colleagues at Princeton. And what he found was that when people were learning about alien species with easy to read fonts, they actually remembered and learned less quickly about those categories than when they had difficult to read fonts. They've also found, actually Beth probably know this, but they've also found some studies where cognitive biases, people are less likely to fall for standard heuristic biases when they have disfluent fonts. They also found that high school students who were given, get this, a physics test textbook with difficult to read font versus easy to read font, that they actually learned better in the difficult to read fonts condition. And, all right, so those are basically just some examples. I'm not sure how far to take this because it may be a one-shot deal, right? Like the first time you run into a low fluency font, you're like, why the heck do they have, you know, this font? And you focus a little bit and then you are a little bit more deeply processing that information. I read a recommendation that they turn all textbooks into difficult to read font, and I was like, that doesn't strike me as intuitively likely to be beneficial. But in any case, at least for the short term, there does seem to be some benefit to making disfluent fonts. In the high versus low contrast visual images, people tend to like high contrast images, but they remember the low contrast images better. So, all right. That's just some examples in the context of fluency. Rich Mayer and Mary Hegarty did a nice series of studies where they tried to create perhaps the perfect animations to communicate things like how brakes work, how toilet tanks work, things like that. And they compared the animated displays to static pictures of toilet tanks, and had people look through each one, read some text or hear some text, and learn about how a toilet tank worked. And here's a picture of their beautiful animated display. And I followed every principle in the book for high quality animations. And what they found was that they could not ever find a benefit for animations in anything. And when you asked people what they liked better, they said they liked the animations. When you asked people which one they learned from better, they said the animations. But when you tested how well they understood the information, it was the static displays. And here's some evidence for this. This is their score on a post-test of understanding. I think there are more questions in the toilet tank example. So in gray is the paper diagrams, and in red is the computer animations, and over again, they find learning to be slightly better for the static conditions than the animated conditions, and they couldn't find a benefit for animations on anything. And sort of a third example I'm going to share is basically active engagement processing, having to put more work into things. And Mickey Chi has always made this argument about self-explanation, looking at a visual display and focusing and explaining it to oneself is far more beneficial than just reading a display. And so in this particular study on risk, what these Natcher and Berry did was they either gave people the numbers and asked them to mark it on the graph so that they got risk information about side effects of a particular drug. They either got a number and in the graph, or they got a number and they were asked to actually fill in the graph so that they could do this. Then they were more likely to remember that information when they filled that information in for themselves. So basically what I'm making a case for here is that factors that increase effort, that force people to make effort in interpreting data, can actually lead to better comprehension and memory. And so contrary to this idea that perceptual fluency, ease of retrieving relevant information is the best thing, that sometimes, especially for learners that you want to remember and learn facts and information from the data, they may actually want to have a format that is not ideal. I should give you two caveats here that I didn't know that I would have time to give, but I think I'll have a moment to give them, which is that if you overload someone's cognitive abilities, so in the case of labels versus legends, further analyses found that the high working memory people were the ones that benefit from having that extra load put upon them. The low working memory people couldn't handle interpreting graphs with legends, and so they couldn't benefit from them. Secondly, you've got to have the disposition to deal with that increased cognitive load, right? So if you don't care anyways, and then you're given an even harder interpretation task, you're not really going to benefit from that increased load. So if you're giving this to learners, say in school, and they're not so excited to learn, you may just get disengagement as opposed to a benefit and increased engagement. So those are a couple of our caveats. We found that low need for cognition people are negatively affected by legends, and high need for cognition people are able to deal with legends. So it's not even necessarily an ability thing, it's also partially an attitudinal thing. Okay, so what are some design implications? One is that we need to stick with maximizing discriminability when immediate, accurate perception is important. So if you want people to get something fast, quick, move on from the information that you're giving them, you want it to be well discriminated, all right? You might want to have irrelevant embellishments, like the picture of the Capitol in the background and stuff like that, if you want to motivate a user's curiosity for group communication where people are like talking about stuff, and when long-term recall is vital. So if you really want them to get the gist of the information and not precisely process it accurately, but you want them to remember that gist for a long time, then maybe the embellishments are the way to go. If they're highly motivated people who just want to get the exact numbers, then you want a simple display, right? Okay. Animate causal or temporal patterns, which are the only kinds of animations that seem to have some potential benefit when the animation is beyond people's spatial abilities. But if they can mentally animate, if they've got the cognitive capacity to mentally animate, they're going to benefit from that. Try static graphs then to induce mental animation, especially in learning mechanical things. That's not a mechanical one, but all right. Label values directly when perceptual judgments may be erroneous, when speed is important, or when users have low graphical literacy. But consider substituting a legend when initial perceptions are likely to be flawed. So if you really want people to go, oh yeah, okay, I see. So if they're just going to look at it and say they think they get it without processing it very deeply, then you kind of want to make it a little harder for them. So in conclusion, I would like to say that graph comprehension is an interaction of bottom-up processes in which format affects what is processed with ease and with difficulty, and top-down factors such as knowledge and expectations. For the fastest and most efficient presentation, you would want to rely on perceptual processes by selecting formatted graphic elements that support the interpretation intended by the designer. But for deeper processing and active engagement, difficulties may be desirable, but active engagement is effortful. So I wonder how long it's been since I last looked at the clock. Maybe it's been an hour. Well, actually, it's probably been only 40 minutes. I guess half an hour, just to be safe. 20 seconds! It's going to be a pretty bad day. So the idea here is that, yeah, so the idea here is that although increasing sort of effortful processing is a good thing, perhaps people can only handle so much effortful processing in their day and or life. And if you give them more than they can handle, you've got to either give them less or change their dispositions towards accepting more. And then I did want to, I didn't talk about working memory training, but I want to thank my collaborators on this work. And I very much want to thank you, and I'm willing to answer questions. It looks like we've got like 4 minutes or something.
Okay, this is really depressing.
Yes.
Because it says that all of the effort you put into making your graph easily to understand is wasted effort if you want people to understand it. Is there any way to get all the benefits from making a bad graph without actually making a bad graph?
That's a good question. So I wouldn't say that all is lost, right? So when you're communicating to people, your goal is often just for them to get that one thing. Our goal in some of these studies was to get them to understand a relatively complex pattern and to maybe discover something new. When you're presenting a talk, you don't necessarily want them to focus on interpreting it in every which possible way. You just want to make a point. And so then you're probably better off communicating it well.
I think this is all task dependent though. I mean, like if you want somebody to just get something quick, then go with the visual, easily comprehensible graph format. But if you want somebody to remember it, then make them encode it more. Is basically what
the other thing though is that experts, when you start looking at graphs for experts, they tend to have automatized the process enough that you can't make it too hard because they look at your graph and go, oh, that's a reaction time function, or that's a logarithmic relationship, and they're just done. They don't need all the extra. So you're communicating to a good audience.
So most of the formats in your experiments are as if somebody is reading a magazine article or a journal article or something like that, or a textbook. But how does a presentation style change? For example, if you were to deliver a good graph, very simple graph, but if it's accompanied by speech, would you expect some kind of supplemental effect of modality or something? Or?
That's a really good question, and we're working a little bit on developing like ideal presentation for PowerPoint type situations and things like that. And our current hypothesis is that because they're listening at the same time, so they don't have any text to integrate with, so that's always good to have the oral with the visual, that breaking it down for them, so in these cases where I'm giving you like, so ideally, when I gave you something like this, I might start off by having just the gray bars appear, and then say, look, if this was a trend that I was interested in, which it's not, but, and then have the orange bars appear and say, look, every single time they're lower, so I do one at a time. So all of those kinds of things is forcing their attention on that whole breaking down the graph process that allows them to get more information from the display. So it would be, I think that having this sort of multiple stage graphs where you only open up certain variables at a time and things like that would be good.
Sure. Thank you.
Sure. I don't know if it's true though.
Read your paper, I guess.
We're trying that right now.
What was the reaction time for the legend versus labels study? Like people spend more time in legends?
Yes, they do, and gosh, if I can remember the magnitude of the difference, I'm sure it depends on the task, but it's quite a bit. It's like 50% more time, you know, it's not like a small difference. Yeah.
I have read a paper that people who have better high working memory are better at interpreting the graphs, and people who have low working memory are better at interpreting the words. So does it mean that, is that true? I like reading graphs better. Does it mean that I have high working memory capacity?
Well,
So-
you're grad students, you probably have high working memory capacity. But in terms of low working memory people, it's correlated with, yeah, I mean, I think it's true.
Mhm.
But I'm guessing that there's a lot of extra factors, right? So graphs are difficult. Like, you actually have to put some effort into interpreting them. And if I read 3 sentences that tell me that people with high literacy read faster, and one other facts and one other effect, then it doesn't take as much working memory to comprehend those. You don't really get a complete picture of the data, but you get the 3 facts that you want someone to take away. So yes, the low working memory people are gonna prefer that and do better with that than high working memory people, because graphs become overwhelming to people's working memory capacity pretty quickly. So I think Graham Halford did this sort of analysis of every time you add a variable, you're kind of increasing the number of comparisons by quite a lot. So you really need some working memory to be able to deal with graphs. And I think too that there's some dispositional connections. So one of the things that we've been interested in recently is math anxiety and graph anxiety. And some people, you ask them, would they rather have text or a number or a graph? They'd be like, I don't do graphs. You know, like there's a good chunk of the population that just feels like they don't do graphs. They really hate them, which is weird to me and you, right? Yeah.
So, thanks so much for such a nice presentation and so much interesting data. I guess if I'm interpreting stuff right, it seems like it's a good bet that essentially a kind of time on task is going to mediate performance. I'm wondering if you've explored whether or not this also mediates the individual differences observed for working memory, for example. So is it that the folks who tend to have better working memory are essentially deploying their resources more, encoding better, then having better performance because of it? Or is it rather something better aligned with the capacity or knowledge interpretation where they can just do more in the same amount of time?
You know, I wish I knew the answer to that question, because it's a darn good question, and right now I can't, I do believe that they don't spend more time on displays, that they are able to just get more out of them, but I don't want to be, I don't feel too confident about that. I know I have the data, and I know I've looked at that, and I think it interacts with the task in complicated ways, and I haven't got a memory.
You made too good of a graph for that.
Yeah. Disappeared. Yeah.
So you talked about there are just some people that don't like graphs, they'd rather read text. Have you looked at is there a way to manipulate the graph to make people want to use it if there's multiple options? You know, if they have like a paragraph versus a graph, how can you make the graph seem more interesting or appealing to people that don't normally like graphs?
We have not tried to make the graphs more appealing to people, so I don't, I mean.
But the home study, the home
Yeah, I
study
mean, the
did that.
home study suggests that all of that extraneous pretty stuff makes people look at them. I assume that's why USA Today continues to print their graphs that way, that people don't mind those graphs, right? So
I don't think they necessarily view them as graphs, it's a picture at that point. It's more of like an animation or a cartoon you're looking at versus a graph.
Yeah, they're not as intimidated by those, I would guess. But in terms of getting people who typically don't like graphs to like graphs, that part I don't know. Sometimes you can convince them with like some of those examples where without the graph, people made horrible mistakes, like the Challenger disaster. You know, have you ever seen, do you remember, you don't even remember the Space Shuttle Challenger, I'm sure.
I've heard of it, yeah.
So my parents' analyses of of the way in which they presented the data about O-ring failures and temperature,
Yeah.
and the argument that if they had displayed the data properly,
Yeah,
they would
that's
have
fine.
noticed that they had a problem, but because of the way they displayed the data, they didn't notice. And I think that's sometimes compelling to people, those kinds of stories, like, well, I should try to look at my data as many ways as possible.
Yeah.
All right, thank you.
Good to know.